Hi guys, welcome to my channel Code and Canvas, and in this video I will show demo on all HTTP concepts that we have learned in the previous video. So if you have not watched that, please go to that video once and then come back to this video. So let us start without any delay. So let us start with the serial connection in which the calls are made one after the other. So let me start the server here and let's go to this localhost URL. And now if I open my network tab and refresh the page, so as you can see, when I'm refreshing the page, there are four calls being made, right? One is for localhost, which is actually giving with HTML response. So the page that is being loaded here with this small HTML. So this comes in the HTML response, and after that, as you can see, there are three scripts written here, right? Three script tags are present here, which are making three respective requests to different files, right? So you can see there are three different requests here as well for different files, right? And here if you will see, the connection ID is different for all of them. So in browser, whenever a browser makes a connection to a server, it just gives it a connection ID, a unique connection ID to maintain it. So as you can see, for each request the connection ID is different, hence the connection is different. So now if you open this waterfall model, right, let's say we open it for this file one request. So you see there is queuing, stalled requests and waiting server content downloaded and everything, right? So as you can see, just a second, yeah, here it is. So here there is a DNS lookup, there is an initial connection, then request was sent, then it waited for the server to send some response, and then finally the file content got downloaded. So in total it took 16.19 milliseconds, and it also shows you how much time it took in each step. So this is the waterfall model. This will be present for every request. So it's, for example, for each file. So as you saw in this file, there is a DNS lookup and an initial connection, right? So in this file as well, there is an initial connection and DNS lookup again, because it's making a unique connection. So when it makes a unique connection, it will just show you this entry. Now if you will look into the code for this, let me go to my code and open the public file and index.html. It's just simple, the same HTML that I have shown you, and I've just created three files with simple console logs. So if you will go to my server.js, as by default browser keeps the connection open. So to close the connection for each request, so that the requests don't use the same connection again and again, I have put a header here. So whenever I send a response, either it's for slash, that is localhost, or some file serving some file, I'm just passing a header here, which is connection with value close. So when you pass this header with close value, the browser will know that the connection doesn't need to be open. Whenever the request will get completed, it will just close the connection, and for further request it will start a new one. So that's all for the serial connection. Let's move to the next demo, which is persistent connection. Let me start the server here and go to this localhost URL. Again, I'll open my network tab and refresh the page. So if I compare it with the previous one, so as you can see here, the connection ID was different for all four of them, right? But here if you see, the connection ID is same for first two, this localhost and file1.js, but the connection ID is different for file 2 and file 3, right? So this is happening because so let's say our first request will be the localhost request, right, which will load the HTML page. The first request that will go to the server will be on the base URL itself, right, and it will load you the HTML page, and once the HTML page is received by the browser, it will parse it, right? So when it is parsing it, it will encounter these script tags. So whenever it encounters the script tags, it will start executing that JavaScript, right? So in this JavaScript, there is nothing, just a request being sent for some file which is present somewhere in the server, right? So whenever it sees these script tags, it will just execute them, and it's making three different calls for three different files, right? But as we are not closing the connection now if you will see the localhost URL, and then if I go in the headers, I'm not sure if it is coming. Yeah, so as you can see, now the connection value is keep alive. So earlier the connection was closed, right? Like if I open the headers in the previous demo, So the connection value was close here, right? But now as here it is keep alive, so connection is being kept open. So after this localhost URL is completed, because it comes, the browser comes to know about these file request only after the script is loaded and executed, right? So once this is done, as you can see, the waterfall model for this is complete. Let me scratch it a bit. So as you can see, the waterfall model for this localhost is complete. Only after that the request for files are going, right? So whenever it's trying to make request for these files, for very first file, for the very first request, no matter the file 1, file 2, file 3, whichever request will go first, it will use the same connection as localhost. Since browser also has a by default capability of parallel request, so the other two requests like file 2 and file 3 requests, they are making a new connection, because by default browser is making a parallel request for these two files. Now if we want to if we want like all these requests should have same connection ID, just to just for demo purpose, like connection is being kept open for all of them, like for all of them to use the same connection, I'll just make a small change. Let me go to my code in persistent connection, and in my HTML, as I'm using a script tag here, right? So it's making the parallel request. Instead of this, I'll just make the fetch calls using fetch function of JavaScript. So here what I'm doing, I'm just looping these files, and for each file I'm just awaiting for a request to get completed before making another. So it will just loop through this file, and it will just make a request for a particular file, and it will await until it gets completed. Then only it will make request to another file. Now let's see what will happen. Let me start my server again, and let's refresh it on this page. So as you can see, now the requests are being made one after the another, right? So as you can see, the waterfall model has changed. Earlier these three requests were in parallel, right? These three green lines were in parallel to each other, right? Now they are one after the another. As the requests are being made one after the another, that is why the connection ID is same for all of them, because they are all using the same connection is not getting dropped. This is because even if you provide a very small timeout, for example, let's see, if I go to my server.js, I have provided a timeout of 10 milliseconds, right, in both of the calls, in the localhost call as well as the files endpoint. I've provided a timeout of 10 milliseconds, but if we see the total time taken here, let me open this set. So it's more than 10 milliseconds, right? 18 milliseconds. If you sum all of them, it's more than 10 milliseconds, right? So connection is being kept open because so this timeout says once the request gets completed, keep the connection open for 10 milliseconds, and whenever the next request is being made, it will again come, right? So it will say once this request is getting completed, it will keep the connection open for next 10 milliseconds. That is why even if the timeout is very small, as until unless the requests are being made, the connection will be kept open. So once the request stops, once let's say all these three requests are completed now, for 10 milliseconds no request was made by the browser for the same domain, then the connection will get closed, and for the next request a new connection will be made. Okay, that's it for this one. Let's move to another parallel connection. Let me start the server here as well and go to localhost. I'll open my network tab here and refresh. Let's wait for a time. Yeah, so as you can see, let me refresh again. It's waiting for some time, it's pending. Now suddenly you see all these 6 requests being made, right? Like 6 waterfalls appeared suddenly, then these 4 waterfalls are appearing. So in the parallel connection, let's first go to the code, what is happening in the code. Let me go to parallel connection code, public and index HTML. So here I have just put 10 images, and for each image I'm just fetching those images using image tag. Okay, so for each image I'm using image tag, right? So what will happen in the initial call, the HTML will be loaded by the browser. So it will come in the response, it will be loaded by the browser, and while parsing, when it will come to this, it will just start executing them. So for each image tag it will make a request for that particular image, right? Now as we know, browser by default has a limit of 6 for a domain in parallel connection, right? Because I'm always I'm using the same domain for all of them, so all of them are going to localhost 3002. So if you open any of them, all of them are going to localhost 3002. Hence the domain is same for all the images, right? For each request the domain is same. So as we know, per domain the limit of the browser for parallel connection is 6. That is why you are seeing something like this. So as the limit is 6 and the number of images are 10, right? So for the first 6 images, for the first 6 requests, whatever it makes for the images, they might not be in sequence, right? Like here you are seeing them in sequence, right? 1 2 3 4 5 6. But if I refresh them again and again, there could be a chance they might not be in sequence. It's difficult to reproduce, but yeah, there could be a chance they might not be in sequence. So for the first 6 images, the calls are being made in parallel, and after those are completed, the next 4 are being fetched. So it's not like that it's waiting for all 6 of them to complete it. It is looking like that because the time taking by these requests are like almost similar, because it's my local, right? So all of them are getting completed in same amount of time, 2.01 milliseconds. So there is a very small difference. So as you saw, as you see, this is being completed in 2.01 second, and this is being completed in 2.00 second, right? Very small difference. But still, as soon as the first request gets completed, another request is being made. So if I scroll it up a bit more, let's say here, so as you can see, they are not completely parallel to each other. So as soon as any of the request gets completed and all these 6, another request will be made. For example, let's say these 6 are being made in parallel, then the first response came within 1 millisecond, and other 5 are taking 2 milliseconds. Then after 1 millisecond only, the seventh request will start. The seventh request will be made by the browser. Other 3 will wait for any other request to get completed. So it's not like all after all 6 gets completed, these requests will be made. As soon as a request gets completed, another request is made by the browser. I guess that's it for this parallel connection. Let's move to domain sharding. I'll start the server here, and now if you will see the output of server here, I'm just starting one server, right? In domain sharding, if you remember in the concept, we use subdomains to manage our resources, right? So that to leverage this parallel connection limit set up by the browser. So here I'm starting two different servers uh, with subdomains on different ports. So here this is our main server for /URL, and for each image that we'll be using, we have 3 different subdomain URLs on different ports as well. So let's go to the code first, and let me go to the domain sharding here. So the setup is same. I have kept the same 10 images, and in the index.html file, I'm just fetching those images from different shards. So as you see in the parallel connection, if I open my HTML file again, here I was just fetching image1, right? There was no domain information here, but here I'm just fetching them from different domains. So let me go to index.html. So each one has a different domain. So first 6 of them, so these 5 and this is going to shard3 domain, and 2 of them are going to shard2, and last 2 are going to shard1. If you go to server.js, I'm starting 2 servers here, one for the HTML page and one for these 3 shards. So for each shard I'm using a different port, and for each of the server that is starting on this port, I'm serving the image. So my serve image function will just take the name of the file from the URL. So from this path, it will just take this name, the last part of this line, and it will just use that name to fetch the file and send it in the response. So now let's see how it will behave. Let's go to this URL and open the network tab and refresh. Let me refresh. Command. Yeah, now as you can see, if you will compare it with the parallel connection, 4 requests were being made after, right? But now as you can see, all 10 of them are going in parallel, irrespective of the limit of 6, because the browser limit is per domain, as we are using different domains here, right? Because we have created subdomains for our server, shard1, shard2, shard3, the temporary names. So per domain it is 6, right? As we have this shard3, we have maximum 6 images on a particular shard. So shard 3 has 6 images, shard 2 has 2 images, and shard 1 has 2 images. That is why all 10 of them are going in parallel. So yeah, as you can see, all 10 of them are going in parallel. So this is how you can leverage the domain sharding. So this is how you can actually increase the limit of a browser, because the domain is different for each of them. So for each of domain, the 6 parallel connections will be there, and all of them are going in parallel. So the complexity here is, obviously you have to maintain your resources manually. So you have to tell them which resource sits on which subdomain. So for example, one of the resource sits in shard 1, but if you are calling shard 3 for that, it will not be found, right? It will return you 404. So you have to manually manage your resources and keep track of them. So if one of the resource moves from one subdomain to another, you have to tell the browser, you have to make changes in the code and everything, right? So it's complex there. That's why people rarely use them. Only for small things these things are being used, but people rarely use it. So let's move to another demo, concatenation. Let me start my server here, and let's go to this localhost URL. So here please ignore these 3 failures. So let me go to the code first for this. So in concatenation, I have kept 3 scripts with simple JavaScript console log. So 1, 3 and 2, and in my index.html I am making 3 calls. So 3 calls I am making using script tag, and one of them is I am making in the query param I am mentioning which scripts I want. So concatenation means loading all your resources in a single call. So instead of loading all 3 scripts in 3 different calls, I'm just using the concatenated call, in which I'm in the query param I'm saying what all the resources I want, and in my response I'm getting all 3. So as you can see, all 3 console logs are present in the single response, and they all belong to different files, right? All belong to different files, but they are all present in the single response. This is called concatenation of the resources. But here the problem will be the same. As you know, we are getting all the JavaScript we need for our website, right? But every page will use a part of them. For example, you could have a very huge JavaScript in each of them file. So what this is one for a route, this is for another route, this is for some other route. But as you are loading all of them in a single request, your page will also load the resource that it doesn't need. So that is why it's not used by the people. They only use it when your site is small, when you have very small resources, that it doesn't affect your page load time or something. Then you can use it, but you have to be very careful while using it, because if you will bundle everything in a single request, then you will be downloading the huge amount of data for each page, and that is not feasible, that is not ideal in real world scenario. Okay, let's move to another one, spriting. Let me start the server here and go to this localhost and refresh my page. So here, as you can see, let's move to the code first. Let's check the code here. In the spriting, it's usually is basically used for images. So here I have put 3 icons, icon 1, icon 2 and icon 3. They are just small images, rectangular images. So in the spriting, you just combine them in a single image. So this is the sprited image. I have just combined all 3 images in the single image, right? So if you will see my image here, sprite.png, it's just a concatenation of all those 3 images, right? So this is what called spriting. Instead of making request for all the images in a different request, you will just make the request to get this image, and you will just use CSS to show them on according to your own need. So if you want only first icon to be shown on your website, you will just use CSS to show that part of the image. And if you want this second icon to be displayed somewhere, you will just display that second icon from that huge image. This is how spriting is done. Okay, that's all about spriting. Let's move to another one, pipelining. Okay, so pipelining is difficult to demo because browser do not support it nowadays. So I'll just walk through you to the code how I try to represent it actually. So if you will go to my index.html here, what am I doing is in the pipelining, you just make the request, another request, without waiting for a response to happen, right? Without waiting for the response of first request, you just make the another request, right? So right now, let's see if I refresh my page. Okay, okay, I have to fetch from here. Yeah. So as you can see, right now I'm using the await, right? So here I've put await. So because of this, only once a request is getting completed, another request is being made, right? But if I remove this await here, let's comment out this part, and let's start the server again, and refresh it and fetch the JSON files. So as you can see, all three of them are going without waiting for another. Obviously here, because by default browser uses parallel connections, it's making three parallel connections to the server and using making all three calls in parallel. But in pipelining, if in earlier days when the pipelining was enabled by the browser, this connection ID would be different, same for all of them. In the pipelining, as you can see, the connection ID is different, right? In pipelining, the connection ID will be same for all three of the requests, and all three of them will go one after the other without waiting for the first request to be completed. That's how the pipelining used to work, but it's not supported by the browsers nowadays because it's really complex and you have to keep track what response belongs to what request, what response belongs to what request and all. So it's not supported by the browser, so we can just leave it as it is. Let's move to our last demo, which is 3xx redirects. Let me open the server here as well and open the network tab. So here I'm just showing all the 3xx status code that you will usually see in the real world scenario. So one is 301 moves permanently. So let's see the code first. Let's go to 3xx redirects and in the index.html. Yep. So I've just put 4 links here, as you can see in the HTML as well. So each link is making a unique call to unique endpoint. So as you can see, there is let me show you first. Let me try to hit this. So as you can see, it made call to 301, but as you can see, there is another call final which is going as well, right? But we cannot see this call anywhere in this HTML, right? So how it is happening? Because this is a 301 redirect. As you can see, the status code of this request is 301, and 301 says it's like moved permanently, like it's a redirect request, right? So if you will see the header of this request, let's see the response header. In the response header, we are getting a location. So it says whenever you get the 301, browser understands that this request has been moved to a different location, and it has to call the location that is being returned by the server in the response header. So it will automatically make the response to this final header, final endpoint, and that is what you are seeing here, and it is the actual request, and it's actually successful. The final destination, it's as 200 request. So this is how 301 works, but this is how every other redirect status code will work. So for each of them, the final request will be going. So if I hit 302 here, you can see again the final call is being made. So even if it is a temporary redirect, it will just go to the final destination. And here as well, we are getting the header, location header in the response headers. Let's try this for 307, the same result. We are getting the same location header here, and browser is making to call to this final endpoint here as well. Let's try out the last one, 308. Same result, right? So the only difference here is 307 and 302, they represent a temporary redirect. They will ask browser like it's a temporary redirect, and later on the request will be served by the same server. And 301 and 308, they represent the permanent redirect. The difference between 308 and 301 and 307 is 302 is 307 and 308 tells the browser while you are making the call to this updated URL, right? The new URL. You cannot change the method, which is request method of the request and body. So request should be exactly same, only the location of the URL will change. It tells browser to not change any of these, but that could be a case in 301 and 302. Okay, I think that is all for this video. I hope you liked it. If you have any doubts or anything, please anything, please post it in the comments and I will try to answer them. Also, if you want me to make video on some topic, please put it in the comments as well.